Hello my fellow CAD lovers, and welcome to this tutorial on how to build a dynamic hexagonal screw block in Autocad. In this part 2, we are going to add geometric constraints to the basic screw geometry we created in part 1. Geometric constraints are all about capturing design intent. Currently, every single geometric element in our drawing is in no way related to other elements. For example, if we grab this cycle and decrease its radius, the hexagon will see no change even if we made it circumscribe about the cycle during its creation. In addition, if we grab the center point of the cycle and move it to the right, only the cycle is moved. Our design intent here was to keep the cycle, the hexagon, and the center lines together. With the proper geometric constraints applied, we are always going to be able to preserve the overall shape. Only the scale will change according to the size of the screw we will be interested in. Okay, enough chit chat, let's get to it. We are going to start by making the entire drawing into a block. And for that, we will type B and E to open the block editor. We select current drawing, then OK. Now the graphic area should look like this. You should have this additional tab named block editor, and if you expand it, it should look like this. On the left side, you should have the block authoring palette available. If it is not the case, click on this authoring palettes button in the manage panel to activate it. Now in the authoring palette, we have these 4 tabs: parameters, actions, parameters set, and constraints. This tab constraints contains the tools we are going to use to create all our geometric constraints. We are going to add constraints to the screw side view first. So Z for zoom, then box select around the screw side view. To add a constraint, we just have to set the desired tool, and for example here the horizontal tool, and then select the desired constraint geometry, here a line. But something very important to know before we dive into fully define our screw is that when creating geometric constraints, it is a good idea to always have at least a known fixed point. This will make the results predictable when the other constraints will be added and edit or test will be performed. So we select the fixed constraint. Now we have to select a point or an object. We will make sure to select the midpoint of this center line, as you can see. Next, we will add coincident constraints. We select this endpoint, then this one. We press enter on the keyboard to repeat the coincident constraint tool, and we are going to do the same on this corner. Enter or spacebar to repeat the coincident constraint tool, and this time the endpoints of these 2 arcs. Now we connect the endpoint of this line with the one of this arc. We will repeat the procedure for this side. The arc with the arc and the line with the big arc. Now it is also possible to make an endpoint coincident to a line. To do so, we will select the endpoint first. Then for the second input, press enter to activate the object option and then select the line. We will repeat the procedure once again. This endpoint first, then enter, and next this line. Again this endpoint, enter, then this line. We will repeat these steps until all the coincident constraints are created. If necessary, zoom in to get a better chance of selecting the correct point. To launch the coincident tool here, I use the down arrow key on the keyboard to cycle through the last used commands. As you can see here, even with this level of zoom, only the midpoint is detected for this chamfer line. We are going to zoom in a little bit more. Down arrow key again, and we select execute tool, and now we are good to go. Now let's zoom out and pan the view like this. Down arrow key, and we select execute tool. This time we select the midpoint of this line, then enter, and we select the center line. Same thing for this line. Enter, we select the center line. Now we type Z and zoom in on this chamfer. Down arrow key, then execute tool. We select this endpoint, then this one. Again for this one and this one. Again for this one and this one. This one and this one. We are done with this side, so we zoom out and pan like this. Now down arrow key, then execute tool. We will select the midpoint of this line, then enter, and then the center line. We pan to the right to bring the screw head in the graphic area, and we are going to connect the midpoint of the base to the center line. Next, the midpoint of this arc to the center line, and the same for this one. Now we will zoom in on this corner, and before adding more constraints, I am going to take some time to fix a mistake I made here. So EX for the extend tool, then enter for select all, and with the shift key pressed down, I will remove this part and this one. Okay, so much better like this. Now we press the down arrow key until the execute tool command is available, and we will connect this endpoint to this one. Next step, the endpoint of this line, enter, and we select this arc. Now this endpoint and this one. Since we want the line and the arc to always be tangent, we are going to add a tangent constraint. We select the arc first, then the line, and now you can see the tangent constraint glyph added near the location where the two entities are tangent. Now we are going to zoom out and pan to get a view like this. We are going to add another tangent constraint between this line and this arc. So we select tangent constraint. We select the arc first, then the line, and now a second tangent constraint glyph is visible. We zoom out and pan again to get to the other side where we are going to perform this previous step again. First, we will fix the mistake, then I will add the required coincident and tangent constraints. Only one trim is required here. Now coincident constraint, this endpoint, and we press enter, then select the arc. Space to repeat the tool, then this one and this one. The same for this side. And now a tangent constraint for this arc and this line. Now we zoom back and pan a little bit like this, and we will add the tangent constraint between the arc and this line. Okay, for now we are done with the side view, so we are going to zoom out and bring the front view in the graphic area. We are going to start by making this center line horizontal, so we select horizontal, then the center line. Next we select the fixed constraint and apply it to its midpoint. Actually, we are not going to do that. Let's cancel. Now a collinear constraint instead between this center line and this one. So what else do we need to add? I don't know, but for sure a good way to find what constraints are missing is by testing your work. For example, here I will try to pull on this corner, and as you can see it moves freely, and his two adjacent sides are not longer tangent to the cycle. The polygon is not longer an hexagon. Ctrl+Z to cancel. To fix that, we are going to start by adding a coincident constraint between this corner and the vertical center line. The same thing on this side. Now we select this cycle and try to move it using its center point creep. As you can see, there is nothing to prevent that. Ctrl+Z to cancel. So we are going to add a coincident constraint between the midpoint of this vertical center line and the midpoint of this horizontal center line. Coincident constraint again, the midpoint of this horizontal center line and the center of this cycle this time. Now we try to move the cycle again, and as you can see the center line moves along, but the hexagon is once again destroyed. Ctrl+Z to cancel. Okay, we need more coincident constraints. First this midpoint, then enter, and we select the horizontal center line. Same for the right side. The midpoint, then enter, and next the horizontal center line. Now we grab this corner of the hexagon, and as you can see the other endpoint is adjusted accordingly to enforce the midpoint constraint we created earlier. Ctrl+Z to cancel. Now we will add the tangent constraints. First between this edge and the cycle, this one and the cycle, this next one and the cycle, and so on. Let's test our work again. This time we will select this creep on the cycle and drag it up, and as you can see the hexagon is resized accordingly. Ctrl+Z to cancel. Now let's try a diagonal move on this corner of the hexagon, and as you can see, while the tangencies with the cycle are maintained, the hexagon is once again totally destroyed. Ctrl+Z to cancel. To fix that, we are going to first make sure the edges keep the same length by applying equal constraints. First object, this edge, then equal to this one. We test it by dragging this corner, and no surprise here, the two edges are kept equal. But what we can notice here is that the vertical center line is not longer vertical. We are also going to have to take care of that later. Ctrl+Z to cancel. We are going to keep adding equal constraints. This previous edge with this one, another one, this to this, and we have this warning: the constraint cannot be applied. It conflicts with existing constraints or would over constrain the geometry. My best guess is that the coincident constraint between this specific edge, midpoint, and the center line is the reason for this warning. The constraint manager cannot resolve successfully both this equal constraint, the coincident constraint, and to a certain extent keep the tangent constraint enforced as well. Instead, we will try this edge and this one. Now let's drag this corner again, and it's looking good. Same for this corner. Now the cycle, and it looks fine. I think we have made a good progress on fully defining the screw front view so far. Let's move back to the side view, and what we are going to do is to make sure that all the vertical lines will stay perpendicular to the center line. So we select the center line and then this first one. Enter to restart the perpendicular tool, the center line, then this second line. We are going to repeat this constraint until all the vertical lines are done. Note here that I could have also simply used vertical constraint. Okay, we are done with that. Now we make sure that the minor diameter lines are perpendicular to the threads and lines. So first one, then second one. Now we move to the head, and first the base perpendicular to this line, the base again perpendicular with this one, the base perpendicular to this line, the base perpendicular to this line, the base perpendicular to this line, the base perpendicular to this line. Okay, now let's zoom out and pan so that we have the entire side view visible. Let's grab this midpoint grip and drag it to see how our drawing behaves. As you can see, the model stays symmetric to the center line. Good. But in this corner, the aspect ratio is not maintained. Let's drag this grip. For now, as you can see, the thread minor diameter lines and the chamfer can go out of whack like this. You are going to have to do something to keep them in the proper location and orientation. But at least here, the endpoints stayed aligned with the threads and lines. Feel free to test your model however you want. This is how you will make sure that everything is working as it should, and eventually catch any mistakes you made and find what constraints are missing. Now enough playing around. Let's hit Ctrl Z a couple of times until we are back to our initial configuration. There we go. Okay, let's pan until we have the head visible in both the front view and the side view. Currently, there is no link between the two. We are going to make sure that the side view is the exact projection of the front view and vice versa. To do so, we are going to simply add a collinear constraint. First between, actually no, let's cancel. We are going to use horizontal constraints instead, since we want to select points. As you can see, we have the 2 points option available here. So we press enter to choose it, and we will select this point first, then the left endpoint of this line. Now if we move this corner of the hexagon, you can see how the side view is updated. Ctrl Z to cancel. Horizontal constraint again, enter for 2 points input, this point first, then the left point on this line and not his midpoint. Okay, let's test again with this midpoint. Doesn't want to move. Okay, Let's try this corner and everything is good. Now we will focus on this corner of the head. We will use a vertical constraint with the 2 points input option and select this point first, then this one. Now the two will stay vertically aligned no matter what happens. Let's zoom out and zoom in on the bottom side, and we are going to do the same for this endpoint and this one. Now we zoom out again and test it. As you can see, the screw head is kept looking as a screw head should, although it's still not perfectly adjusted. One thing which is obvious, and it was for quite a time now, is that the overall size is not similar between the two views. One more thing we are going to have to handle later. We are going to actually take care of that right now. So Ctrl Z to cancel, then horizontal constraint, enter, then this endpoint and this one. Now for the other side, horizontal constraint again, enter for 2 points, then this point, if I am able to select it, finally, then this one, and we have this one in. We click on OK to dismiss it, and let's cancel to C. Maybe we do not need that last constraint, and as you can see, we do not. The bottom side is correctly updated. Now all we have to do is to find a way to keep the oblique lines in the correct positions. These tangent and coincident constraints are not enough. Ctrl Z to cancel. We are going to do that by adding an angular constraint parameter later in part 3. For now, more testing. Feel free to do more than what I am showing here. I cut out most of my testing during the edit to keep this tutorial short. Now this look crazy, but it is actually very good. We are getting close to the end. Ctrl Z to cancel. Okay folks, I am getting really tired here, so we are going to end this part here. Next part we will add a different kind of constraints, the dimensional constraints. I hope I will see you there, and again, thanks for watching.